this is a really comprehensive body of work that we have taken 3 years to develop, that's taken expertise from across our membership, from across the sector, from our government partners.
Welcome, listeners, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well. Thank you, Nate. We have two guests today. Our first is Suzanne Lemieux. She is the Director of Operations Security and Emergency Response Policy at the American Petroleum Institute. Our other guest is Tom Aubuchon, the President and Principal Consultant of Ethosecure Consulting and a Principal Author of the API 1164 Standard. And we're going to be talking about that standard, the new third edition of the American Petroleum Institute's Standard 1164, which is entitled Pipeline Control Systems Cybersecurity.
All right, here's you with Suzanne and Tom.
Hello, Suzanne. Hello, Tom, and thank you for joining us today. Before we get started, can you tell us a little bit about yourselves and about the good work you're doing at Ethosecure and at the American Petroleum Institute?
Thanks, Andrew. We really appreciate the chance to speak with you today and talk about the good work that we've done on 1164 to produce our standard pipeline control system cybersecurity. The API is the primary and largest trade organization representing the oil and gas industry. We have just about 600 members, and as an ANSI accredited standards organization, we've produced over 700 standards that draw on best practices and expertise across the industry that are used around the world, with over 400 incorporated by reference into regulations around the world. I am the Director of Operations Security and Emergency Response Policy. And in that role, I serve as the lead for all cybersecurity efforts within API that help our members create best practices like 1164, address regulations and legislation, and promote what the industry does from a best practice perspective. And with that, I'll turn it over to Tom for his introduction.
Thank you, Suzanne. And thank you, Andrew, for the opportunity to talk about 1164, which I believe is one of the most important outputs to occur in the control system cybersecurity space in decades. So I am Tom Aubuchon, President and Principal Consultant for Ethosecure Consulting, and I focus on providing IT and OT cybersecurity program convergence services to try to get to a single program operating both environments. And I was the principal author of API 1164 and a co-chair of API 1164 working group to develop this third edition.
Our topic today is the new and third edition of the API 1164 Standard Pipeline Control System Cybersecurity. Can you tell us what's new in the document? Can you tell us, where the document came from? Why is this the third edition?
As an anti-accredited standards organization, we have certain rules we have to follow regarding our standards and their updates. And so every 5 years, we're required to review the standards to see if they need to be updated. And with the increased focus on pipeline resilience and reliability, we saw that there was a need to expand 1164 from just SCADA, which was the original focus, to the broader control system cybersecurity landscape. And so we underwent the last 3 years, which Tom was leading on, an effort to really look at comprehensively across control system cybersecurity within the pipeline sector to add more content and to create a framework that could really enhance the standard and broaden the scope to improve pipeline cybersecurity on the control system side.
So basically, if you looked back at the edition 2, it was more guidelines based, if you were, and not really standards based. And so much had changed, and because cybersecurity changes so rapidly, so much had changed since the previous edition that we had to actually step back and think from the ground up what we need to do differently. And what we came up with was we had to do everything differently. The intent and the scope had to be different. And since form follows function, we believe that the structure ultimately needed to change. And since the National Institute of Standards and Technology, the NIST cybersecurity framework had been published. Everybody's moving towards that as the framework by which you would build a standard. We decided to follow that same format. And so we're actually following the NIST CSF to develop an implementable, repeatable, and a measurable set of requirements, i.e. that would make it a maturable security program if you have those elements. And so the whole purpose was to develop a standard that you could then go actually implement the requirements of, to be able to measure your performance and then mature it as time went on.
Andrew, before you get into the deeper details of this, I'm not familiar with 1164. Could you just tell me a bit about it?
Sure. 1164, the API 1164 is one of the first standards ever to come out in the control system cybersecurity space. It was published in 2004. The first SP99 or ISA/IEC 62443 standard came out in 2007, 3 years later. So this is one of the first. It's all about cybersecurity for petrochemical pipelines, and it describes, a full security program. This is again before there was a NIST framework. This is one of the pioneers in the space standards wise, and this is the third edition of the standard coming out that we'll be talking about.
And admittedly, if I don't know that much about pipelines, what do I need to know going in to understand the rest of the interview?
In my understanding, and I've done some work with pipelines in the past, we're talking mostly petrochemical pipelines. So we're either talking oil or refined petrochemicals like gasoline or jet fuel flowing through the pipeline, or we're talking natural gas. So either way, we have petrochemicals. Terminology-wise, in a petrochemical pipeline, in a liquids pipeline, you have pumping stations that push the liquid through the pipeline, every few, tens of kilometers or miles. In a natural gas pipeline, you have, they call them compressor stations, but in a sense they're the same. You have the station every 10 kilometers or so to keep up the movement of the fluid in the pipeline. In terms of the big consequence that everybody in the pipeline wants to avoid is they want to avoid any kind of leak of these petrochemicals, be they gases or liquids, into the environment. And, if you leak enough of the wrong kind of stuff into the environment, there's obviously an environmental damage risk. There's a fire hazard. There might be an explosive hazard depending on, natural gas in the atmosphere. So leaks and ruptures are a very big deal. There's a technical thing that I'd have to get an expert in to explain, but it has to do with shock waves. If you manipulate the pipeline in exactly the wrong way, and it's possible to send a shock wave through the liquid in the pipeline so nasty that again, if you manage it exactly the wrong way, it will actually rupture the pipeline and again produce a leak. So, you have to manage these pipelines correctly. Another term that you hear in the pipeline, the thing is that the pipeline operator 9 times out of 10 does not own the hydrocarbons that are flowing through the pipeline. The pipeline is what's called a custody transfer mechanism. So that's another high priority, is keeping track of every drop of oil or gasoline or whatnot, every, cubic meter of natural gas that flows through the pipeline, so that the people who do own those things, because they tend to sell, from the producer to the consumer through the pipeline, to get those details right, so the billing is right and all of the measurements of how much money each of the participants is owed is accurate. This is all called custody transfer. You've both talked about expanding scope. Suzanne, you said expand it beyond SCADA, and the SCADA system is the wide area network feeding an HMI at a central site, presumably controlling part or all of the pipeline. What is there beyond SCADA? What other kinds of control systems are you talking about now? Are you talking, did pumping stations or compressor stations not used to be in scope? What does bigger mean?
Yeah, so that's a very good question. So what you have, SCADA stands for Supervisory Control and Data Acquisition. And so it has a supervisory role, and operators sit in front of screens and they send down commands and they get back data to operate the pipeline. the SCADA system itself is not operating the pipeline. It has to send commands down to the local control systems. And this could be at the pump station or compressor station. It could be a meter station. It could be a remote operated valve site, things of this nature. And so those local control systems are mostly digital nowadays, and they are interconnected through these networks. And so the Edition 2 only focused on the supervisory control elements, not local control. Edition 3 of API 1164 covers both aspects.
And I've had an opportunity to look through the new edition. What strikes me as sort of different from the previous version is that the new edition, the first thing that struck me was it uses a lot of 62443 terminology. I see a lot of zones, a lot of conduits. What's the relationship between this document and the IEC 62443?
As I said earlier about the new structure, we're following the NIST CSF. But if you back up even further, this is for oil and natural gas pipelines. And the Transportation Security Administration, the TSA, the same organization you see at airports, they're responsible for the security of pipelines as a mode of transportation across interstate lines. And so they actually have some guidelines. They've mapped their guidelines to the NIST CSF. And so we're trying to follow the TSA guidelines and the NIST cybersecurity framework. The NIST cybersecurity framework has informative references in them pointing to other standards. ISA 6443, also known as IEC 6443, is a set of those standards that have the informative references point to. And also the NIST 853, 882 pair of standards are in those informative references. We found that those informative references within NIST were not sufficient within the ISA 62443 set of standards. That set of standards is scheduled to be 13 different documents. They're only covering 2. So we went to ISA and asked for limited use permission to use and reference their standards in the creation of API 1164, and we're granted that permission. ISA 62443 is a generic control system cybersecurity standard, and is best in class in that space. And so we wanted to leverage that because we did not want to be reinventing any wheels in this process.
So, Nate, that was a lot of acronyms. Let me run through them real quick for anyone not familiar with them. The NIST CSF is the National Institute of Standards and Technology Cybersecurity Framework. The framework is, in a sense, a checklist of everything that you might want to consider in a complete security program. And you might have heard, pillars of the framework are sort of sets of items in the checklist that have to do with identify, protect, detect, respond, and recover. 62443, the IEC, is, of course, the standard that the International Society of Automation, the ISA, their Standards Process 99, SP99 working group creates the standard, hands it over to the IEC. They, look at it, they massage it a bit, and it comes out as their 62443 series of standards. There's 14 documents planned in the standard. NIST, again, their 800-53 standard is sort of the gold standard for IT cybersecurity, in a sense, for all cybersecurity. It talks about security controls, everything from, complex passwords, password complexity, through network segmentation, through anti-malware, all of these tools that are part of specific controls that are part of a security program. And NIST 882 applies 853, and to a degree, the other standards, applies them to the industrial cybersecurity domain. So all of these standards, our guests here have identified as, in a sense, foundational to the new 1164 third edition.
Did you know that power plants are exempt from 1/4 of NERC-CIP requirements when those plants use Waterfall's unidirectional security gateways? NERC-CIP does not demand that power plants use the gateways, but the regulations recognize the strength of unidirectional protections. The regulations reward sites who use gateways by dramatically reducing the number of security rules for those plants. For details on the exemptions, please download Waterfall's latest report on the NERC-CIP standards. You can find the report on the waterfall-security.com website in the Resources tab under eBooks and White Papers.
So this document has been out for a couple of months now. What kind of feedback have you folks been getting about the document?
Yeah, that's a really good question. So we have had a lot of positive feedback, but we've had some corrective feedback also that I think needs to be addressed. So we've had some feedback that this is a prescriptive standard because it is so extensive and in depth. But if you actually think about the kinds of standards that there are, we were very cognizant of ensuring we were not prescriptive when we wrote it, with the drafting team was. And some folks believe that, if you go beyond just telling them that they need to apply security to their cyber assets, then if you go beyond that, then you're being prescriptive. But there's actually a legal definition of what a prescriptive standard is. And it basically specifies the sole means of compliance with performance measures by specific actions, measurements, and other quantifiable means. It's a documented process or procedure for guidance in the implementation of an activity. In other words, it focuses on how something should be done. API does not focus on the how. It is a descriptive standard, and it focuses expressly on the quality, kind, and condition of what is denoted in order to achieve a desired outcome. So API focuses on what should be done, not how you must accomplish what should be done. And so that's the difference. So we don't get into the how, and I'll give you an example. So if you have a security requirement that says you have to have strong passwords on administrator accounts, that's descriptive. If you say your strong passwords must be of at least 16 characters long, include all 4 character sets, etc., that's prescriptive. You're telling them exactly how to go build a strong password. And we don't cross those boundaries.
That makes sense. The standard is, I mean, you talked about prescriptive versus descriptive. The new standard is longer than the old one. Why is that? What's the extra stuff? Are we talking extra controls, extra detail? Why is the standard longer? What's the added value there?
What we're looking at, and this is also some feedback we have received, that there are so many security controls. And this is a misnomer and misuse of terminology within the cybersecurity and information security spaces as to what is a security control. What we actually have defined in our standard are security requirements. And if you look at NIST, has a definition of what a security control is. And it's a safeguard or a countermeasure prescribed for a system or an organization designed to protect its confidentiality, integrity, and availability to meet a set of defined security requirements. 1164 is that set of requirements. They are not in and of themselves controls. Often, you will have multiple requirements within 1164 will be incorporated into a single control. So if you have, say, 20 requirements, you would boil that down into 5 controls. So people will say, we have a lot of controls in there. We disagree. We have a lot of requirements. We were very detailed for specific reasons. What you often find in the vague language of some standards and even some policy statements, there's opportunities for misinterpretation between the assessor and the SSE. And we wanted to avoid that at all costs, because it costs enormous amounts of angst and lost efficiencies and effectiveness of the security program. So we avoid using what's known as scope expanding conjunctions. We don't say this and that, or this or and that, and then commas start having real important meaning and interpretation of the comma and what is applied to the and beyond, and all those kinds of discussions. We eliminate all that by using very short, concise statements that don't expand, so that and some repetitive language, which is some other pushback we've gotten, is very repetitive. But the idea is that you can extract some of these requirements and set them off to the side and go do them without having the entire document at your disposal. And so there are very specific reasons why we're so detailed and so short in our requirements, and they are not actually controls.
My first impression of the document, I looked through, and it has all the components in there of the NIST framework. There's identify, there's protect, there's detect, respond, recover. It seems to cover the whole spectrum. But there's a whole chunk of the table of contents that seems focused on these profiles. What's the word profile mean in the standard, and why is it so important?
We're following NIST CSF. they have identified that you could have profiles for different scenarios. And often folks look at those profiles to be different scenarios of different industries. So you could have a manufacturing profile, you could have a banking profile, you could have whatever. We actually took it a step further and we said within the pipeline space, we will have multiple profiles. And those profiles are related to impact, to common business objectives. And so it is an accumulation of security requirements to protect against a potential impact level and a particular level of sophistication and intensity of security threat. So the more that something could be impacted, the more security needs to be applied to protect against a more sophisticated attack. And so there's a correlation to a profile, which is a collection of security requirements, should be addressing a level of impact that can occur to protect against the threat of a certain sophistication level. So an extended profile is for advanced persistent type threats where you could actually have loss of life and limb and property and environment could occur. You got to apply the most stringent risk requirements possible in those categories.
Okay, so with that overview, let's dive into the details. I did manage to get through the standard ones. I got some questions, specific ones. If people want to look it up, it's section 4.2.2. It says safety instrumented systems are out of scope for the document. But our safety instrumented systems, are these not some of the most important systems that we need to protect in a cybersecurity program? Why are these things out of scope?
So the short answer is yes, they are absolutely something you need to protect from a cyber perspective when they are digital in nature. Not all safety systems are digital in nature. Some are mechanical and pneumatic. Those would certainly be out of scope of any cybersecurity standard. The ones that are digital, what it comes down to is that 1164 basically states that the safety systems that the standard can be and could be applicable to safety systems. But the 1164 does not deal with the security integrity level known as the SIL, selection or determination calculations. There are other standards for that. IEC 61508, IEC 61511 deal specifically with SIS and SIL SIL selection and determination. Security measures applied to safety systems can have impact on this SIL determination. And 1164, that is out of scope. It's out of scope for us to understand and to provide guidance on how it might impact safety systems. And so what we said is it's out of scope for that. The requirements in 1164 can be applied, but that it's on the implementer's risk to do so because we're not addressing the SIL selection and determination piece. Right? There's probably a better wording we could have used, and instead of saying any use of the standard in SIS environments is at the implementer's discretion and risk, we probably should have said any use of the standard in the implementation of SIS is at the implementer's discretion and risk. So you can select the requirements, but how you implement those requirements in a safety environment may be different than how you would apply them in a pure control system environment.
But the word safety appears 49 times in the document. I went and counted it. It's like every third page or so talking about how protecting safety is vital to the cybersecurity program. So, how can protecting safety be vital if we're not addressing SIS? There seems to be a gap here.
And that's a really good question and a really good point. There are actually two different aspects of the safety equation. So when you're mixing of operational safety requirements of say, a traditional control system and the functional safety requirements of SIS is not really advisable. SIS deals with functional safety and only that, only functional safety, not operational characteristics, not trying to meet operational objectives. And it does not, and it should not incorporate these things, right? It is the last stop, check valve, safety gate, whatever, for ensuring safety. A control system operates under the guise of performing essential functions, and that's the capability required to maintain health, safety, environment, and availability of the equipment under control. And within those constraints, they're designed to keep the process under control within safe limits while achieving the operational objectives. So the parameter can range between 1 and 100, and they got to keep it in between 1 and 100, and that's a safe range. And you can't go below 0, and you can't go above 100, and you keep things operational. SIS doesn't care anything about that. It cares only about the safety. So the use of safety in this context is that neither operational safety nor security objectives can, say, override an essential function unless it's supported by detailed risk assessment. An SIS system is the last resort to ensure safety, so risk assessments are irrelevant. You don't override a safety system, pure and simple. And let's take an example. So SCADA system stands for supervisory control. It can send a command to the local control, and it could either be, say it's an operator error, it's an HMI screen error on the SCADA system, and the operator actually is allowed to send an illegal value down. Or it could be for nefarious intent. Maybe the SCADA system's been compromised, right? The local system should ignore that command because it's going to put it outside of its safe operational parameters, okay? But let's say there's an error in the programming of the control system, or it has also been compromised. And it actually accepts that invalid value and goes beyond the safety limits programmed into the control system. The safety system is there as the backup to ensure bad things don't happen. It does whatever it needs to do to keep things as safe as possible. It will take the safest path possible to either shut down the system and say, you could have vent natural gas to the atmosphere to prevent overpressurization, because that's less damaging than is, say, a pipeline rupture that actually explodes. And so it's going to take it's going to take safety over everything else. Nothing else matters.
Andrew, I had the same question as you there. Operational versus functional safety. It seems to me that, safety is safety.
Yeah. So, this is something that I got out of this episode. I, historically didn't know that there was a difference, but, in the, talking to Tom, both the piece we have here and, some of the other conversations I had with him in the course of getting this recording, it has become clear to me. Let me suggest, let's start at the top. We're talking about the difference between a safety system and a safety program. In the safety program, the operational safety program, the top layer of safety is a human operator. In many jurisdictions, it is illegal to operate a petrochemical pipeline blind, without human supervision, for more than a handful of tens of seconds, like 10, 20, 30 seconds, and you must shut down if the human operator has lost control, has lost visibility into the pipeline. So human supervision is required. The human operator is, safety is a big deal with the human operator, but the operator has other priorities. And the operator is operating the software. The HMI is a big deal, human machine interface, but there's other software behind it, supporting software between the HMI and the devices in the field that you're controlling, the valves and the pumps and the compressors. Let me just give you a couple of examples. I saw a list of some 17 priorities that, industrial operators often had simultaneously in their heads and were trying to manage. Obviously, safety is one of them. But, we talked about reliability. The pipeline's not much good if it's not shipping anything. So keep the pipeline going. Contractual obligations, we have to get fluid from A to B. Let's make sure that's happening. Reliability of the equipment. If you minimize heat load on the equipment, the heat differences, you minimize wear on the equipment. But often, you also need to minimize the energy, the amount of energy that's used to push the fluids from one place to another. And often minimizing the amount of energy maximizes your heat load. So you've got conflicting priorities in the heads of these operators. You, of course, have a priority to, minimize your environmental emissions as well, and, minimize the amount that you need to use your repair crews or your maintenance crews, and ideally arrange operations so that maintenance occurs during the day, during working hours, instead of when you're paying overtime. These are all priorities in the head of the human operator and sort of in the software system that's managing the pipeline. So yes, safety is a big deal, but this is only, the operational safety program is only one of the layers in the layers of safety system, and the lower level system they're calling the functional safety system. That's the SIS that has only one job. So that's what I got out of this. One of the sections, if you want to look it up, 5.2.1, the cybersecurity plan in 1164, it defines risk tolerances. It says the amount of risk an organization is going to tolerate is a function of the organization. Every organization has a different degree of tolerance. But if we're talking petrochemical pipelines, if we're talking oil or natural gas pipelines, public safety is involved. A lot of pipelines, public safety or not, these pipelines constitute critical infrastructure. Society depends on natural gas going to the power plants and keeping the lights on. So, it says the risk tolerance is per organization, but is there not a common minimum risk tolerance that society demands be applied uniformly across the entire industry?
Yeah, so within API 1164, the third edition, in section 4.4, we define 6 common business objectives, and they include, among others, maintain human health and safety, maintain environmental safety, and maintain property safety as some key business objectives. And the cybersecurity that you apply is in protection of those objectives. Okay, and then 5.2.1 of this document is defining the elements for a formal cyber risk strategy, which is a crucial element of a risk management program. You have to have that in place before you can actually make risk management decisions on whether it's an acceptable risk or not. All right, so then we have those elements built out within the standard. And it requires an organization to understand its role in critical infrastructure. And that's in the CSF mapped into 1164 as the identify function risk management category. And there's a subcategory of critical risk tolerance in there. And so there are a lot of requirements around understanding and defining your risk tolerances based on where you are in the critical infrastructure and dependencies you have on it or it has on you. And so that's an element of some of the pieces that are at the company level, trying to understand where they play in that space. But as a descriptive standard, that's about as far as we can go. If we got into this is the minimum floor risk tolerance element, you're now defining bright line risk requirement rules, and that's not appropriate for a descriptive standard. That's a prescriptive standard. That's more along the lines of regulation, is who drives those bright line rules. Now, having said that, the oil and gas industry has the most mature and embedded safety culture of any industry I've been involved in 4 decades. Nobody else has safety meetings and safety moment discussions before every meeting and every gathering. And this includes business and IT meetings. It's not just your field operations folks having these meetings. Every meeting starts with these. Everybody playing in this space, including Suzanne's organization, they do the exact same thing. It is a culture. If you're going to be a member in this community, you have to abide by the safety culture. And so all of that is baked into this. So the risk tolerances that these companies have regarding safety is really close to zero tolerance for safety of any kind. And they actually have goals for zero. They call it zero is achievable kind of mentality, right? We can achieve zero safety instances.
I actually really liked the original question that you asked there. I'm wondering, Andrew, what is your personal view on it? Do you have one? Should there be a societal standard for safety risk in industrial security? Or is it okay that we're leaving this up to individual site overseers?
Really, what we're talking about here is the difference between sort of standards or guidance and regulations. And no industry wants new regulations. Most industries are already dealing with a lot of regulations. Already they don't need another 1 or 2 or 3 sets of regulations. But there's a problem. Generally speaking, when governments become concerned that there's a discrepancy between the amount of risk that a critical infrastructure operators or an industry full of operators, when there's a discrepancy between the risk that those businesses are deciding is tolerable, a discrepancy between that and what the society is thinking, what the public is thinking is tolerable. When there's these different expectations, this is where you start to see governments and regulators, sending orders into the industry saying you have to do more. And this actually brings us to our next question, which is there was an order that came out recently from the TSA. So let's go back and listen in. There was a presidential order shortly after the Colonial Pipeline incident, and it directed pipeline operators to carry out a lot of security measures. In my understanding, one of the elements of the directive was, deploy security sufficient to keep your pipeline, to keep the OT systems running, even if the IT network has been compromised, for example, by ransomware. If, and 1164 sort of came out before this, but if a pipeline operator applies 1164 principles diligently and methodically throughout their pipeline infrastructure, will it achieve that goal? Is 1164 enough to keep the pipeline operating even if IT is compromised? Or is that in some sense a different animal? Can you speak to that?
Yeah, so I really can't speak to the security directive that came out. There's certain information in there that's not allowed to be shared outside of certain circles. But what I would say is that this question is really dealing with business resiliency and business continuity. And can you keep your essential operations running or not? And 1164 is a cybersecurity standard for control systems. And a proper cybersecurity program, including, proper cyber hygiene, is, an element of the resiliency and continuity equation, but it is not the equation, right? There's some of the variables in there, but it's not the entire equation. So, there are major dependencies beyond the scope of any cybersecurity program, regardless of whether it's IT or OT. And those include things like the staffing level and the skill level of the staffing level and the robustness of your business processes and how tightly coupled your systems are and your data layers. A lot of that has nothing to do with cybersecurity. So we're a player in this equation, and we're not the driver of the whole outcome. And so there's no security standard on the planet that can satisfy an objective that says a security standard will keep this environment running, because that's not the role of the cybersecurity. It plays a piece of that. It is part of that answer, but it's not the entire answer. And so it's kind of the way that is currently couched and worded. There's not a standard on that can actually satisfy, a single standard that satisfies it, because the scope is beyond any standard.
So let me chime in as well, because API did provide comments before and after Security Directive 2 was published by the TSA, that we feel they missed the mark a bit on the concern over IT versus OT reliability, and that if your IT is compromised, you can continue to operate your OT systems. In certain circumstances, such as the Colonial Pipeline ransomware incident, they shut down their OT operations out of a concern that the ransomware could have moved from IT to OT. So it was really abundance of caution that they made that decision. And so always saying, well, I can keep my OT running while my IT is compromised isn't necessarily the right risk decision in a certain circumstance. And so that's really, there's a broader look at your whole network and where you might have connections that you need to be aware of before you make those types of decisions.
Suzanne mentioned there that what you're talking about is confidential. So why the heck are you telling me, Andrew?
That's a good question. The original TSA order was limited distribution, and I never saw it because, the government decided I did not need to know. So all I know about it is what other people have said about it. And most of what I know about it, there was, the Washington Post published what appeared to be a redacted version of the order. So if that publication is accurate, that's what I've based my comments on is my reading of that version that was alleged to be the TSA order that was published by the Washington Post.
And it sounded like there was some disagreement here over it.
That's right. I mean, Suzanne made the point that the API had opportunity to provide feedback on the TSA directive before the directive was issued, and their feedback apparently is it's on the public record. They disagreed with the order, whatever it was, whether what was in the Washington Post was accurate or not. So yeah, it does sound like there's disagreement here, and between the government and the industry, and it'll be interesting to see how that disagreement resolves over time.
And what do you personally think it would take to resolve the conflict?
That's looking into the future, but I will say that I had a look at the document, the redacted document that was published by the Washington Post, and it sort of had a high level objective: keep operations running even if IT is compromised. And then it had a whole bunch of very specific measures that it said you have to do this, you have to do that in support of this objective. I looked at those measures, I added them up in my head, and I said, even if a pipeline operator did all of these measures, I don't think it's going to achieve that goal of, in a sense, guaranteeing that the pipeline can keep operating even if IT is compromised. So I agree with Suzanne in the sense that I'm not sure that the directive, as published by the Washington Post, if that was the directive, I don't know that the measures add up properly to achieve the goal that the directive set out to. We've done the deep dive into a bunch of the details here. Can we come back to the big picture? Suzanne, especially, the API organization put this standard out a few months ago. People have been using it. You've been getting feedback. How's it working? Is the community embracing this standard? Is there a resistance? How's it going?
I think it's going well. Obviously, with any framework that you're implementing within your organization, there are going to be challenges as you mature. I mean, we've seen this with cybersecurity programs across the industry, across other industries. And so this is a really comprehensive body of work that we have taken 3 years to develop, that's taken expertise from across our membership, from across the sector, from our government partners. These are consensus-based standards, so we do have a broad group of experts that create them. And so implementation, it was published in August. It wasn't published because of the Colonial Pipeline incident. It was published because it was ready. Again, 3 years of work put into this. And so as companies start to implement it it's going to vary based on what their maturity is or was before and after they decided to adopt the standard. But it's going to take time, and we're going to see changes made. We have a continuous feedback process with this standard because of how technology changes and how the cyber threats are changing. And so we're going to see continuous improvement within the standard itself, and then continuous improvement within the industry as companies adopt this. Again, our standards are global, so we'll see this around the world, and it's going to be implemented based on what different regulations companies are complying with overseas. Domestically, of course, we have SD2 here in the United States for the top 100 critical pipelines. And so how they implement 1164 with SD2, we're going to see those lessons learned continue to be shared as we move into 2022 and beyond. So we're excited about the standard being published. We're excited about companies beginning this journey, because it is a journey of maturity. And we look forward to seeing how we can improve the standard to adapt to the changing threat landscape.
So this has been great. I learn a lot from experts like you. Showing me how to parse these complicated standards documents. Before we let you leave us, is there a thought you'd like to leave with our listeners?
We hope that operators are open to looking at 1164, seeing how it can work within their systems, coming along on this journey with us as we try to improve pipeline control system cybersecurity. We know there are a lot of concerns about pipeline reliability, both from consumers, from users, and from our government partners. That's why we've developed this standard to help our industry mature. And so we really look forward to continuous improvement and adoption of 1164 as we see threats to critical infrastructure grow. And these are really good ways to help our industry be secure and reliable.
So 1164 When you think about the NIST cybersecurity framework, is just that it is a framework. It is not implementable as it is. And 1164 is an implementable version of the CSF, specifically for oil and natural gas line pipelines. And you consider there's almost a virtually limitless number of challenges and a very limited number of resources that you have to apply to them. 1164 provides you with guidance on how to deploy those resources for the most effective use within your control system cybersecurity space. So you're highly encouraged to get a copy of 1164 as soon as possible and get on with this program. It can be rolled out in pieces. It's not a one and done, and it's not all at once kind of a program. So I just encourage you to go get a copy of 1164. And start reading through it and getting engaged with API if you need to for further guidance and so forth, because it's very important in this control system space, and this will help you get there.
Andrew, how about a last word to close us out?
For people who are trying to get a copy of the standard, they can go to api.org. And look under their standards publications. They've got a web store. You have to pay for it. It does cost $200 US. And having heard the conversation here, I'm certainly going to reread the standard with all of its profiles, with looking at it as a deliberate attempt to synthesize 62443 with NIST and with these other sources. And I'm going to ask the question when I reread the standard: is this really what we should be expecting all of our standards to look like as they evolve? I think that's a question worth asking when you read this standard.
Then with that, thanks to Suzanne Lemieux and Tom Aubuchon for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.